So before we start our presentation, we are going to show you a simple video to help you understand the concept better. So sit back and enjoy. Yes, so quite interesting, right? So basically in this video, the bot uses reinforcement learning to teach itself to cross the wall, jump across obstacles, and etc. So let us share with you what is reinforcement learning about. So reinforcement learning is actually a type of machine learning technique that allows the machine to learn based on trial and errors and without any data and human supervision given to the machine. So the machine actually learns how to perform a certain task through its own actions when interacting within the environment. So why is it powerful? So and many times in the real world, data collection is sometimes expensive, and also not a large amount of data is available if you are trying to solve a specific problem that is hard to collect data. So therefore, the reinforcement learning allows us to solve larger and more complex problems. So it also forces the machine to take action to maximize reward rather than learning through data, as well as mimicking the action of a human expert, which means that it can be much more effective than a human expert himself. So reinforcement learning is becoming increasingly popular in the real world. So the first real world application that made reinforcement learning popular was the AlphaGo. So can I check how many of you have heard of AlphaGo before? Yes, so quite a number of you, right? So this AlphaGo is actually created by Google's DeepMind in 2015. So it was the first computer program that played the board game Go. And basically it's something like chess. And then it's also the first AI that beats the Go world champion with no handicaps given at that time. So the machine was trained using reinforcement learning techniques that helps it to identify the best move to play the game, which allow it to be even better than a world champion. So reinforcement learning is also used in other industries such as supply chain as well as gaming industry. So for example, the robotic arm you see in the picture, it actually taught itself how to package goods more effectively using reinforcement learning technique. So the technique is also widely used in the gaming sector, and one example is the OpenAI's Dota bot, which has won several professional players as well. So how does reinforcement learning work? It actually is, reinforcement learning is often modeled as the Markov decision process, where the machine, which is the agent in this case, is learning from its continual interaction with the environment to achieve a goal. So the agent will perform a certain action, and the environment will respond to this action and present new situations to the agent. So through this process, reinforcement learning will force the machine to learn through trial and errors and find the best optimal policy to maximize rewards. So to help you understand this concept better, let's use the game of Pac-Man as an example. So in the game of Pac-Man, where the goal of the agent, which is the Pac-Man, is to eat the food in a grid, while avoiding the ghost on his way. So the grid world is an interactive environment for the agent, and Pac-Man receives a reward for eating the food and punishment if it gets killed by the ghost, which means it loses the game. So the states are the location of Pac-Man in the grid world, and the total cumulative reward is Pac-Man winning the game. So to find the optimal policy in the Markov decision process, we can use several algorithms to solve this problem. Next, I'll pass on my time to Zuoling, who will share with you what are some of the algorithms available.
Okay, just to start, I'll introduce the multi-arm Bandit problem, which actually provides a simplified analogy of this agent environment model. Okay, so like imagine you're at a casino, then there's like 3 slot machines in front of you. Okay, so like in case some of y'all don't know what's a slot machine, basically it's like a machine where you put a little bit of money inside, after then you get a chance to win a large amount of money, okay? Okay, so like in this case, how would most of y'all actually devise a strategy to maximize your rewards? Would you all actually try all the slot machines, or would you all look for a slot machine that works for you and continually try that? So this leads to the explore-exploit dilemma. Okay, so what is this actually? Okay, so to explore is basically to take a risk and to choose an unexplored option, while to exploit means to choose the seemingly best option at the moment. However, both sides has their cons. Like for instance, to explore, when you're exploring, you can waste computing power and time on a bad option. While if you're exploiting, you can the choice that you're exploiting might not be the actual best choice. So to simplify things, just imagine there are like 3 doors in front of you. Okay, so if you open the first door, you get $10. If you open the second door, you get $2. And if you open the third door, you actually don't know what you're gonna get. So what would you hello? Okay, so which door will you open in this case? Some of us might actually open the first door because they value like security and stuff. So you know that you're gonna get $10. Okay. So sorry. Okay. A few others might actually open the third door because you might hope for something. You might hope for more money than $10. Okay, but you're taking a risk in that case. Okay, so like to solve this explore-exploit dilemma, okay, so the reinforcement learning agent actually needs to find an optimal solution with minimal experimental effort. So to do this, the algorithm needs to employ a mixture of explore and exploit. Okay, so some algorithms to do this may include the A/B test, the Epsilon greedy algorithm, the upper confidence bound algorithm, or even a Q-learning. Okay, so for the sake of this presentation, we will only cover the A/B test and the Epsilon greedy algorithm. Okay, so first I'll cover the A/B test. So basically, you test every single slot machine equally. Okay, so for instance, for each of the 3 slot machines, you pull each of them 100 times, and then you draw an inference from the end result. So why is this not feasible? Okay, so this A/B test is purely exploration and followed by pure exploitation. So you test each of them 100 times, but then you waste time and computing power to actually test the ones that are not the best. Okay. Also, this is difficult to apply in the real world to complex tasks. Like for example, if I'm teaching a robot dog how to walk, there's more than 3 possible actions as opposed to the multi-arm Bandit problem in this case. There's like, I don't know, 1,000. So you cannot expect the robot dog to actually test every single of these actions. It would be very inefficient. Okay, so that brings me to the Epsilon greedy algorithm that I actually want to present to you all. Okay. Okay, sweet. Okay, so how this thing works is that you set epsilon. Epsilon is like this Greek letter. It's just a variable to 0.2, a small probability. Okay. So at the start, you first test all the slot machines to figure out which one is slightly better for you. Okay, so that's after the first iteration already. So from the second iteration onwards, for each iteration, you generate a number from 0 to 1. Okay, so if the number is smaller than epsilon, you actually explore and then you pick any of the slot machines randomly. However, if it is more than 1, you exploit and then you pick a slot machine with the currently best percentage of success. So after every time you pull the slot machine, you recompute the percentage of success for the slot machine, and then you repeat the steps. Okay, so now I'll do a short demonstration of how this actually works. Okay, so now can I have one volunteer to set the probabilities? Can you just shout out 3 probabilities? Anyone?
0.2.
Okay, 0.2. Okay. Next. 0.9. Okay, wow. Okay, let's set it slightly lower so that for learning purposes, okay. Okay, the third one, like maybe 0.4 or something. Alright, okay. Okay, so like I'll just walk you all through this epsilon greedy thing. Okay, so the first iteration will explore all of the slot machines. Okay, looking good. Okay, so this is the first iteration. Now we have our best option, correct? Okay, so now we generate a random number. Okay, so it's more than 0.2, so we actually exploit the best machine now. Okay, looking good. Let's try again. Okay, still exploit. Oops, okay. Still exploit. Okay, let's assume that this is actually explore. Okay, so when we explore, we actually pick one of the random machines, okay? Okay, so now because we are exploring, they asked us to pick the third machine. Okay, it didn't work. Let's try again. Okay, explore. Okay, too bad. Okay, so anyway, in the long run, the more we do this, the scores of the machines will actually converge to the actual probabilities of the slot machines. Okay. Okay, so as you can see, the score is actually approximate to the actual probabilities of the slot machines. Yeah. So with this algorithm, the machine learning, the reinforcement learning algorithm can actually learn which one is the best course of action. Okay. Yep, so that concludes the end of our presentation.
Do you all have any questions for us? Okay, no, then thank you.